Hi everyone, this is our Unit 6 practice test, trigonometric functions. Be sure to pause whenever you need to, it's going to go fast, and also to review the textbook sections that are referenced. So first we have section 9.1, which is things you would have learned in geometry class. So use trigonometry to find the height of the building to the right. Over here there's a triangle already drawn in, and we know the hypotenuse, we know an angle. We want to know this height that's across from the angle, and that would be the opposite side. We can call that x. Now if that's opposite, we can use opposite over hypotenuse, which is sine. So sine of 57 degrees equals x over 300. So x is 300 times sine of 57. Be sure to use degree mode on your calculator to calculate that out. So under mode, mine is already in degree mode, so I can hit second quit to get out of that. 300 times sine of 57 degrees, and I got 251.6. However, I need to add this extra 5. This was not part of the triangle, so plus 5, and that's going to give me a final answer of 256.6 feet. Next, find the value of each unknown side, no decimals, so simplified radical form. This is talking about special right triangles. Here I have a practice test from the SAT, no calculator, and what they give you are some references for special right triangles. So we need to know that these ratios. If you need to, just pause the video, write those down. But here we have a 30, 60, 90 triangle. You know if it has a 60, this has to be a 30. We know that this is the hypotenuse right across from the right angle. It is going to be double the shortest side. The shortest side is half of it, half of 6, so that would be 3. The medium length side, or other leg, is going to be square root of 3 times the shortest side. It's about 1.7 times as much. They're always in the same ratio. But we're looking for simplified radical form, so it's just times square root of 3. 3 root 3, and that's all. In the next one, we have a 45, 45, 90. These ones are really easy because the legs are both the same. They're congruent, so 7 and 7. The hypotenuse is always square root of 2 times the leg, so 7 times square root of 2, and that's all. The last one, we have another 30, 60, 90. It's just flipped around. We're given the shorter leg. You can know that because it's across from the smallest angle. 30 is the smallest angle. That's the shortest side. We're going to double it to get the hypotenuse. And we're going to take that smallest side times square root of 3 for the other medium-sized leg. Moving on, we want to convert to degrees. So we need to know what is equivalent, what is our conversion factor. I use the unit circle to know that right over here, pi radians is equivalent to 180 degrees. Since those things are equivalent, if we write them in a ratio, it's a form of 1. Anytime you're doing unit conversion, you're multiplying by a form of 1. So you're keeping your quantity equivalent, you're just changing the units. So here I want the pi to cancel, so I'm going to put pi in the bottom. And pi is equivalent to 180 degrees, so 180 degrees goes on top. Again, this ratio is a form of 1. When I multiply this out, the pi's cancel, and I'm left with 15 times 180 divided by 4. Put it all in your calculator and you get 675, and degrees is the remaining units. In number 4, we're doing the opposite. We're converting to radians, and we want to keep in terms of pi with a reduced fraction, no decimals, because that's convention when dealing with pi. So here I want degrees to cancel, so I'm going to multiply by 180 degrees is equivalent to pi radians. When I put the degrees on the bottom, then they cancel. And I'm left with actually negative 140 pi over 180. Here you want to use some elementary school math to be able to simplify that fraction. So I can divide the top and bottom by 10, and that will cancel the zeros. I can divide the top and bottom also by 2, and that will simplify it further. So 14 divided by 2 is 7. 18 divided by 2 is 9. And we're left with negative 7 ninths pi. In number 5, sketch the angle 13 pi over 6 starting at 1, 0. So what that means is conventionally we start over here and we move counterclockwise in circular fashion to sketch angles in the coordinate plane. Now think about it, 12 pi over 6 would be, because 12 over 6 is 2, that would be equivalent to 2 pi, and 2 pi is 360 degrees, or 1 time around the circle. So what I'm going to do is I'm going to take this all the way 1 time around the circle, and then I have a little bit more because I have 1 pi over 6, so it's plus 1 pi over 6 more. And so that's going to stop right here. That is an 30 degrees, or another pi over 6 that it's equivalent to. So to calculate the trig ratios required here, cosine, sine, and tangent, I'm just going to look at my unit circle. On the unit circle at this location of 30 degrees, or pi over 6, the x value is square root of 3 over 2. That is our cosine. The y value is 1/2. That is our sine. And our tangent is y over x. So cosine, you just copy it. It's square root of 3 over 2. Sine is going to be 1/2. Tangent, we have y over x. So I'll just write that out. It's going to be y over x, or sine over cosine. And so it's 1/2 over square root of 3 over 2. And the denominators cancel here. Those 2's cancel. We're left with 1 over root 3. Or you can rationalize the denominator, but it's not required. So that's a good answer, 1 over square root of 3. And number 6, graph at least one period of the function, specify the midline, etc., and you choose how to scale the graph. So we're just looking at the different parts of the graph. We have A, B, and K. We aren't using H in this one, but A tells us, so this is our A value, that tells us the amplitude, or how stretched the graph becomes vertically. So amplitude is going to be 2. The midline is the plus k right here, but there's a 0 really, so the midline is at y equals 0. This is the b value of 1/3, and that's going to be needed to compute the period of the function. So first of all, min and max, if it's going, 0 is the midline, that's where the function can be folded in half vertically. That means it's going to go up to +2 and down to -2. Back to that b value, period is 2 pi over b, so you have to do a little bit of a calculation. So maybe over here, I'm just going to do period equals 2 pi over b, and b is 1/3. When you're dividing by a fraction, it's the same as multiplying by the reciprocal, 2 pi times 3 over 1. So we're left with 6 pi as our period. This means instead of repeating every 2 pi, this function is repeating every 6 pi, so it is stretched out horizontally. Over here, I'm going to reflect that in how I scale this. So I do have a little picture here of the original or parent function, sine function, starts at 0, 0, goes up to its max, comes back down through midline, down to its minimum, and back to the midline at 2 pi. But in this function, it's going to be at 6 pi, and instead of going up to 1 and down to -1, it's going to go to 2 and -2. So that's all I need to do as I sketch this graph. So this is a 2, this is a -2, the midline is still 0, 0, or y equals 0. I need 4 tick marks, 1, 2, 3, 4, and over here is going to be 6 pi. Over here is going to be -6 pi. Sine function starts at the midline. A quarter of the way through that period, it gets to its max, goes back down, then goes to its minimum, and that's one period right there. So this is all that's required for the test, but you can also sketch it over on the negative side as well if you'd like to continue over here. But that's all that's required. Moving on, I have about 5 minutes to finish the back side, so I think I'll go through one of these. That's a cosine function. So I think I'll go on to B. We have to write the equation. We can see that the amplitude is 4, so A equals 4 because it's from the midline of 0 going on up to the max of 4, minimum -4. What is the period? And the cosine function starts at its max, drops back down. Now this doesn't show a whole period right here because we would have to go all the way up here to see it, but where would that point be? Let's take a look. So if we start 0 and then this is pi, well, it looks like I'm just doubling that, and that would be 2 pi. So that's the same as our parent function with a b value of 1 because period is 2 pi over b, and right here we have 2 pi is the period. So b has to be 1. I'm going to fill that all in rather quickly. Y equals 4 times the cosine, and b value is 1, and so you just see cosine of x. Let's move on to our Ferris wheel problem. It's 80 meters in diameter and rotates once every 6 minutes. The center axle is 55 meters from the ground. We need to draw the picture, and remember, center axle is right there, and that's 55 meters up. I'm also going to draw lines at the max and the min and the ground. It's 80 meters in diameter. That means the radius is 40. This is equivalent to the radius right here. If you think about it, that's the radius. So this is the radius. And here's another 40. If the center axle is 55 from the ground, but the radius is 40, we can subtract off that 40, and we're left with 15 as the distance to get to that minimum spot from the ground. What's our maximum then? That would be 15 plus 80, so 95 to the very top. This is where we can use some common sense to put this into the graph. So at 0, we're starting at 15. 0 time, we're starting at 15 meters off the ground. It takes 6 minutes to come back to that spot. Halfway through, that's where you're going to get to the max. The max is at 95. So at 3 minutes, you're at 95. Here I'm just going to go ahead and connect it with that smooth curve. And that's one cycle. Now we need to write the equation. We have all the pieces except the b value. So think about period is 2 pi over b. And period, when it comes to using time as our independent variable, is time per one cycle. Oops, sorry. Or time per cycles. That's just the units that are associated with period. And we know it's 6 minutes for one cycle. So that's one way we can do this, is through using period. We can also use frequency, which is just the reciprocal of this. So really quick, frequency is going to be b over 2 pi, and that's going to be cycles per time. And that means one cycle per 6 minutes. This makes it really easy to solve for b because you just have to multiply by 2 pi each side. When we do that, we get b by itself, and b is pi over 3 if you simplify that fraction. Now that we have all the pieces, we're going to put it together, but keep in mind, what kind of function are we using? Back to our parent functions, sine functions start at the midline. Cosine functions start at the max. However, we can flip this function by making the a value negative. Anytime we put a negative in front of a function, it flips it over. In this case, it's midline. And so that max, it'll actually get flipped to its min. And that's what happens in the Ferris wheel situation. When you start on a Ferris wheel, you typically start at the bottom or the minimum spots. So we're going to use a negative cosine function. The amplitude is equivalent to the amount that you're traveling from the midline to get to the max. That's 40. The k value, the midline itself, is 55. We found the b value was pi over 3. So putting it together, our function h of t is negative 40. That's our a value times a cosine of 1/3 or pi over 3 times t. You can put those in parentheses if you'd like. And this entire function is bumped up by a k value of 55 meters off the ground. I have about 1 minute here to finish up our last problem before the bell rings. And so in this problem, you want to draw the angle between pi and 3 pi over 2. So that would be down here. We're given that the cosine is negative 1/6. Cosine is adjacent over hypotenuse. Use the Pythagorean theorem to find the remaining side, and you should get square root of 35. Keep it with simplified radical form. From there, use SOHCAHTOA to find the rest of the trig functions. So sine is opposite over hypotenuse, square root of 35 over 6. Tangent is opposite over adjacent, square root of 35 over -1. Then go ahead and flip each one to find the reciprocals, cosecant, secant, and cotangent.